Question number 9. In the given triangle PQR, right angled at Q, PQ is 30 centimeter, QR is 40 centimeter, QS is perpendicular drawn on hypotenuse PR. Circles with center O and O dash are inscribed in triangle PSQ and QSR as shown in figure. Find the distance between the centers O and O dash. Well, let's use the triplet. Since 30 centimeter can be written as 3 into 10 and 40 can be written as 4 into 10. So it's a triplet of 3, 4 and 5. So the length PR is going to be 5 into 10, which will result in 50 centimeter. Now, in any right angle triangle, whenever we draw a perpendicular from the vertex containing 90, we get 3 triangles, and each of the 3 triangles, the one smallest one, the other one medium sized and the original one, all the 3 triangles are right angle triangles and they all are similar. So we are going to use that concept to find out the value of the things that are required quickly. So if we look at the triangle PQR, this is the largest triangle. Then if you look at triangle QSR, this is the medium sized triangle. And if you look at the triangle PQS, this is the smallest triangle. Okay, so I'm going to write largest, medium and smallest. So for the largest triangle PQR, the hypotenuse, let's take hypotenuse. The hypotenuse is 5. If we talk about triangle QSR, the medium sized, the hypotenuse is 4. It's the ratio that we are more concerned about. We can take 50, 40, 30 also. And for the smallest triangle PQS, the hypotenuse of this triangle is 30, in other words 3. Since these 3 triangles are similar and their hypotenuse or corresponding sides are in the ratio 5:4:3, that means every other linear attribute of the 3 triangles will fall in the same ratio. That means if I talk about the in radius of the 3 triangles, the largest triangle, if I draw a circle which is not drawn, the in circle of the triangle QSR and the in radius of the circle of the in circle PSQ, they will also fall in the same category. So let's find out what is the in radius of the largest triangle if it was 50. So I hope you know how to calculate in radius. The in radius formula is given as altitude plus base minus hypotenuse whole divided by 2. This is how you calculate in radius. So if I look at the largest triangle, the in radius is going to be altitude plus base minus hypotenuse whole divided by 2. 70 minus 50 is 20. 20 by 2 is 10. So we see that if 5 represents 10, as in if the largest triangle has an in radius of 10, then the medium sized triangle will have an in radius of 8 and the smallest triangle will have an in radius of 6. So we figured out the in radii of the 2 circles pretty quick without thinking about how to calculate the length QS. So this is 8 and this one is going to be 6. Now, what we are asked is, what is the distance between O and O dash? So in order to understand the distance, we need to understand one small part. That is, if we have 2 circles that are separated by a stick or a wall, then the 2 circles, their centers are not going to be in a straight line with the point of contact. Okay. What it means is, if I take these centers and if I join them, then they will not be meeting at the point of contact. Had there been no wall or the separator between them, then that would have been true, that the distance between the 2 centers would have been the sum of the radii. Right now, 8 plus 6 is not the distance between the 2 centers, and 8 plus 6 is 14. You can look at the options. No option says 14. That also gives us a hint. So how do we deal with this? So from here, can we say this is 8 and this is 6? And this is 6 and this is 8. Sorry, this should have been 8. So if we look closely how this figure is going to turn out is we have a length 8 here, we have a length 6 here, then we have a length 8 here, we have a length 6 here, right? So if I reduce the height, okay, let me draw the circles again. So this is circle with radii 8, separator. We have another smaller circle with radii S6. So this is 8. This is 6. This is their base. So if we need to find out this distance, I'm going to draw a line parallel to the base, which is going to give us a right angle triangle here. So this pink triangle is a right angle triangle where this length is going to be 2. Why 2? Because this height is 6, which is same as the radii of the smaller circle, and the entire distance is 8. So this smaller part is going to be 2. This length is 8 and this length is 6. That means this entire length is going to be 14. So using Pythagoras theorem, we are going to calculate it because 2 and 14, they don't fall in a category of triplets. So it's not a faster way. So we can say that this is the hypotenuse of this pink right angle triangle where two sides are 2 and 14. So 2 square plus 14 square, which is 4 plus 196, which will give us under root 200, and 200 can be written as 10 under root 2. So this is the distance between the centers of the two circles. 10 root 2 as in option C.